Ladies and gentlemen, welcome back to Amateur Repair Time. Today we're going to work on this beautiful item here. This is a Magnaflux instantaneous demagnetizer. Have you ever even heard of such a thing? So lately, I've been working on radios and clocks mainly, and record players a little bit, and trying to learn about them. But lately I've been messing with watches a little bit. So for instance, I've got this pocket watch here, little cheap little dollar watch. It's an Ingram Viceroy, whatever Viceroy means. And I've got it running, but these things weren't really known for keeping great time. they lose several minutes a day usually, and the parts were kind of cheap, so they wear, and then they lose more time and stuff like that. But one of the reasons that a watch will lose time or gain time is because, usually I think it's lose time, is because it's magnetized. So I was talking to my friend Matt about this, and he was saying, well, I thought brass didn't hold magnetism. And I don't know about that, but the little spring in there, the little hairspring, so that spring is winding up back and forth, right? And that's what kind of pushes the balance wheel around and makes the whole thing work. Well, if that spring gets magnetized, it'll stick together or be drawn to stick together or whatever, and it'll change the speed that the watch runs at. So all that to say, it's good to have a demagnetizer. So this thing is actually made for that. It's also made for tools, so you can take like a little screwdriver that the tips became magnetized and put it on here and demagnetize it. So these are real helpful for doing watch repair, putting the movement on. So I bought this thing. This is like a kind of high-end one, believe it or not. I usually don't want high-end stuff, but this thing I got a good deal on, and I thought it was cool, and it didn't work. So I figured we could fix it. So this was on eBay. And again, it's the Magnaflux Instantaneous Demagnetizer. You hit this button and it goes bzzz, and it demagnetizes everything. It's the same as what we use on, or it's very similar to what we use on arcade monitors whenever we do the degaussing ring, if you've ever seen that. We've got a big ring and we hit a button and it creates an electromagnet, I guess, and that fixes, we use that to fix degaussed, or is it gouged, monitor tubes where the colors are all screwed up because of magnetism. So it says a Troop Ballas product, B. Jadow Inc., New York City distributors. That'd be interesting. All right, so there's a button on it, and it's a bad button. Look at this. It's like blow up the outside world. And then it's got a jeweled bulb. Okay. And it's got like what seems to be like a Bakelite case. It's got 4 little feet on the bottom that are like plastic, like a plastic rubber, that rubbery feeling plastic. And then it has this little label. I figured we'd read it, we'd try it, and then we'd take it apart. What do you think? So it says Troop Ballas & Co., Philadelphia, 6, Pennsylvania. Whatever that means. Patents pending. Laboratories, Ariel, New Jersey. So this must have been a huge company. Think about it. They're in Philadelphia. The laboratories are in New Jersey, and the things are distributed in New York. New York City? Okay, so let's read this. Troop Ballas. What kind? Is that Italian or something? And my Italian's not great. Instantaneous demagnetizer. The new Troop Belass and Company, Magnaflux Demagnetizer works on an entirely different principle in removing magnetism from watches, tools, instruments, and precision parts such as those found in the watch industry and the instrument trades. I always have found it weird that back in the day, whenever they would hyphenate words, they would just break it anywhere in the word when they could have just changed. I guess they couldn't change the spacing because of the way things were printed. I don't know. You know, it's before computers, so you couldn't really quickly change spacing or anything. But like, so they put EN dash entirely. So entirely. But then if you look there, I guess the spacing's the same. And this was INSTRU dash mints. Okay. Building up a high voltage and storing it in a capacitor until needed. This charge is released by pressing a switch, sending the surge into a specially engineered coil assembly to produce a magnetic flux intensity more than twice that of other capacitance demagnetizers and more than 18 times that of some air core demagnetizers in use today. Thus, items which were non-demagnetizable before may now be easily demagnetized. That's right. With this bad boy, you can demagnetize things that were non-demagnetizable before. To use. Place watch or object to be demagnetized in the center of the target area. Place small objects into a small box so that they will not jump and be lost. They'll go all across the room when you blow up the outside world with that button. I want to see that. I want to see the crap. We're going to try to make stuff jump off of it, because if that's a thing, it will be a thing I get on video. Only one surge of flux is needed in most cases. This must have been what the good Doc was using to go back to the future. In objects of unusual shape or cases of wide magnetic dispersion, another surge may be desired. If so, wait 5 seconds between pressing the switch for full voltage to build up. This thing sounds dangerous as hell. I love it. And they made the button metal. Awesome. The magnetic flux surge is instantaneous, and while there can be no harm in holding the switch button down, the storage capacitor will not start to charge up until the button is released. The unit may be left plugged in continuously since it uses less current than that used by an electric clock. And then, unfortunately, I can't read the unit number all the way. Unit number 105-500, number missing 94. I wonder if there's a dash there past the 500 because they knew that was going to wear away. What you think? Like, you know, when you were writing on it, you would see that there's a bump there. So maybe you wouldn't write a number on the bump, you'd put a dash or something, and then we can dream, can't we? All right, so that's pretty cool. So this looks to me, with this pressed board, but with the plastic or Bakelite, whatever it is, case, I'm going to say 40s. I'm going to say late 40s. Early 50s. What do you think? Is that too early? I don't think it's any earlier than that. So I'm going to say 1948. That's my final guess. 1948. So, all right. So we're going to take it apart and look inside, and there may be a date on the cap or something. So let's plug it in and see if it does anything. So you see what they say. You just press the button. And then you have to wait 5 seconds till the next time. All right, so let's see if it does anything. I will say it has a modern power cord on it. which I don't like because that means somebody's been in there. That power cord, there's no way that's from the 40s. There's no way that's from the 70s. It's in such good shape. Well, it might be from the 70s. Okay, so somebody's already been in it. Yeah, so the light's not on. I don't know if it goes on when you hit the button, whenever it does the flash, if the bulb comes on. I would think that the bulb would be on, and then you hit the button and the bulb goes out, is what I would think. Nothing. So let's put some trash on it here, just to make sure. Because if it's working, from what I understand, the stuff will fly across the room. It might be working just fine. Let's try it again. Oh man, it's working. The bulb just isn't working. So they sold it to me as not working. I'm just trying to make sure that I'm not, that hitting this isn't making the stuff jump. Look, that's not gonna do it. If I do that, it doesn't do it. Right? So it's not that. This thing's actually working. Well, that's cool. So I think the bulbs just burn out. Can we get to that from the top? We're still going to open it up because why not? Yeah, I think the bulb's just out. It must be doing whatever it does, or that stuff wouldn't be jumping like that. So let's try it with you. Yeah, definitely. Definitely, right? Or maybe this place is haunted. Okay, that's probably not it. All right, let me see if I can get that bulb out of there. Okay, so I was able to get the bulb out of the top. We're unplugged, by the way, and I hit the button. So hopefully this sucker's drained. If not, you may never see this video. Okay, so I pulled the bulb out. It's a pinball bulb, actually. It's a number 47. And I checked the resistance across the bulb, and it seems like it's fine. It looks like it's fine, too. So I'm wondering if there's just something, a wiring problem or something. So let's see how this thing works. So the power comes in through here. They have it attached here and here. Yeah, I think somebody's repaired it at some point. I think I'm way too early on the date of this thing, but that's fine. Okay, is that it's saying something up there, or is that just worn? Let's see. Well, if it ain't written in hieroglyphics, that's just worn. So the power comes in. One side goes over here to this big cap. It's kind of hard to see. I don't want to break anything. I'd like to leave it together as much as possible. Okay, so one side goes there. And then there is a wire jumping off of there. A little metal wire. Going to that, which... what is that? Is that one of those old silicon rectifiers? I don't know. I have no clue. Okay, and then the other side goes to the switch, I believe. And the switch has 3 wires. That's fun. Let me look at that a little closer. Well, I've been going through, it's plugged in right now, by the way, so don't touch it. I've been going through it and looking at everything and checking voltages. I can't see anything wrong with it other than the bulb won't light up. But it kind of seems like, and by the way, I'm like 5 inches away from it. It's an optical illusion. It kind of seems like that the bulb is only supposed to light up whenever the magnetic field disappears or whatever. So I think maybe the bulb is supposed to flash when the coil does its thing. But I've never seen any kind of design like this. So if you look on the bulb, one of the legs has the AC attached to it from that switch. So you can measure 120 volts AC on either leg because, you know, the bulb is basically a 4 ohm resistor. So that's about 4 ohms resistance across the bulb. So since it's just sitting here, you got 120 volts on both sides of that if you compare it to the other AC line that comes in. If you check the voltage on the green and the brown wires, right, you have no voltage because it's got the same voltage on each leg. So there's no 6 volt differential to make it light up. And they attach over here. So the brown wire isn't connected to anything except the bulb. And it comes back over here and is connected to that lug right there. It's connected through that resistor. I can't check that resistor, but it seems fine because, well, I went, you know, it could be that resistor is completely fried. I can't test it in circuit because if you look, it's actually connected across the coil. So one leg, the brown wire, connects there to that side of the resistor. The other side of the resistor is on this capacitor, on the common terminal, right? There is also a wire that you can barely see, but it snakes down under it, this brown and white, that connects to this side of the coil. So this coil is connected to the brown wire, and it's connected to the brown wire, and it's connected to the other side of this resistor. So this resistor goes parallel with the coil. I don't understand the design of that, but that's what's going on. Okay, and then the green wire, okay, I told you wrong. Okay, so the green wire connects to one side of the coil. The coil is like 4 ohms or whatever it is. Well, I don't even know. I guess I need to check that next. And then it connects over to the common, which connects through this resistor to the green. So when I check this resistor, instead of getting what I believe is, so that's 10, it's 100,000 ohm resistor. Is that right? Let me think. That's a 22K, I believe. I'm running through the little nasty limerick in my head. Or not limerick, whatever it's called. So it's 22.3. Yeah, 22,000. So that's a 22,000 ohm resistor, and it checks out as that in circuit. Which would make this one a 220,000. Yeah, no, not a 220,000. A 10 and then 4 zeros. So 100,000. So there's a 100,000 ohm resistor. But it checks as like, 100 ohms or something. So it's probably just checking the resistance of the coil. But I don't even understand how that would make the bulb light up anyway. So the bulb, maybe it's some kind of error thing or something. Maybe it just lights up if there's a problem. I don't know. But the bulb has 4 ohms resistance across the terminals with the bulb in. If you take the bulb out, there's no resistance across the 2 terminals. These 2 are capacitors. There's 5 capacitors basically. So this is common and 0.1 and 1. And then this one is common 0.1 and 1. But it's also a resistor, I suppose. Approximately 630 M. Yeah, I don't want to mess with it too much because obviously I don't know what I'm doing. Amateur repair time has its limits. So this says 380 and they've marked it out and put 420. So I'm wondering if that's a 380 microfarad capacitor, and then they measured it and it's actually 420. So any of you people that took electrical engineering or anything, or even probably an entry level in electronics class, can probably tell what this design is, but I cannot for the life of me. Okay, so then you've got these up here. Those look like the old school diodes to me. So I think those are silicon rectifiers. And that one, is it silicone? I think that's right. That one looks pretty rough. So when I check over here, I've got 120 volts where this resistor connects. I've got like 9 volts in the middle and then 120 volts on the other side. And then that connects over to there. So I'm going to see if I've got 120 there and blah, blah, blah. So I'm just going to check all those terminals and see if I've got voltage on all of them or if that last one maybe is screwed up. Okay, so I cleaned that off a little bit, but you know. So then I started thinking, it kind of looks like a bridge rectifier. It looks like they've got 4 areas, and it looks like a primitive diode, which is how a bridge rectifier is made. So I've got 120 here, 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 and here. Or it ends up being like 112 or something. It changes a little bit, but I've got a high voltage AC on these. On both of these, I've got a lower voltage AC. So this one's like 16, this one's like 13. But if I check DC, I've got like 144 here. And if I check from here to there, I get like 144. So it's creating a DC voltage. I just don't know what they're doing with it. So it comes over here to this capacitor. And so I just don't get what's going on. This is the common of the capacitor. If I drew it all out on a circuit, I might be able to tell it a little bit better, but I'm just not, I'm reaching the limits of my abilities here. So you've got one of the lines of the AC comes in and connects down there, and then connects through this resistor, which is a 220, so it's a 220 ohm resistor to there. And then it connects with a capacitor to both of the 144 volt. What I'm getting for the 144 volt. Like I said, if I drew it out, I could probably see it better. But even then, I don't know that it would help much. I don't even know that the light's supposed to come on. It's a nice light with a jeweled face. You would imagine that it must do something. Okay, so the other one comes in and connects here to this cap, but it also connects to what I think is the bridge rectifier. So it connects there. So the one AC is connected through capacitors to what I think are DC voltages. And then the other AC is directly connected to what I'm calling the bridge rectifier. Look, you've got 2 of the legs tied together. Usually the other 2 are tied to the other side of the AC, but that's not tied to that. Or are it? be damned, it kind of is, isn't it? I don't know, folks. I just don't understand it. But you know what I do understand? Maybe I can tell if it's working by seeing if I can demagnetize something. Okay, folks, I plugged it back in and put it all back together. So let's test and see if it's doing what it was already doing. Yep. Maybe even better. Maybe it's better because I cleaned off that diode. Or that rectifier, whatever it is. What do you think? So I have a little cheap screwdriver. It's all rusty, and I think it's magnetized. Yeah, it's magnetized, and it's not supposed to be magnetized. Man, it's pretty strongly magnetized. Okay. What do you think? Did that work? I have seen it all. I have seen it all. We just did electrical magic. Electronic magic right there in front of your face. I wish there was a fancy dancy light to show you that it worked, but you just saw it work. Now, can you even... You can't even... There's no way you can argue. There's no way you can argue that that didn't work. Of course that worked. You just saw it. You just saw it work, folks. Okay, so I think what I'm going to do is there is an app you can get on your phone, and you can get it near things, and there's a compass. They can use the compass on your phone, or there's some kind of magnets on your phone, believe it or not. It can tell if something's magnetized. You can actually download an app to do this. So I'm going to download an app, and I'm going to see if that watch is magnetized. I think about all of them are. And then we're going to zap it and see if that stopped it from being magnetized. Or that's the plan, man. Okay, so I did do it. I used the little app, and I took a screenshot, and I just showed it to you. So that's what it told me. So basically it said 0. I put this clock on the screen, this watch on the screen, just like this. And now it said that number, which was 254 or whatever. So we're going to zap it one time and just see what the reading is after that. Wow. Wonder if that made it might have automatically made it sound a little better. Who knows? Okay, so I'm going to do the same thing, calibrate the little app, and then I'm going to test it again and see what it says. Well, as you can see from the pictures, it didn't demagnetize anything on the watch. So I'm wondering if watches just have an inherent magnetism that app is going to pick up all the time. So I think what I'll do now is I'm going to see if the app can pick up the magnetism on that screwdriver that we demagnetized. So if it says that the screwdriver is still magnetized, even though I know it's not because we just demagnetized it, then I'll know that app just doesn't work very good for what we're trying to do. So let me see what it says about the screwdriver. Okay, so it looks like there's some inherent magnetism just in anything. So the range on that doesn't seem like it's proper. So like I checked the screwdriver and it still says the screwdriver's magnetized, but we saw that it demagnetized. So I think just the range is off. So I think if something truly was magnetized, it would be pegging the thing. And so we're checking things that just have a little bit of magnetism that basically you can't get rid of, or at least this can't get rid of. So I think I'll try another watch though, just a random, maybe just a movement outside of the the case and see if I can get a high reading and then lower it with this. I'm just trying to figure out if this thing's even doing anything. I mean, I know it is because we saw it do it on the screwdriver, but is it going to be useful for these watch movements? Okay, so this one says like 59, whatever that is. It's not strong enough to move like a big movement and bounce it around. We'll wait a few seconds and then, well, no, let's just do it once because it said you should be able to do it one time. Okay, so let me try and see what it is now after zapping it once. Well, it did lower it, but I mean, it went from 59 to 32. I don't, these numbers don't mean anything to me. So I've got this one. I think this is a Elgin. Look, the crystal's messed up. So I think we'll measure this one just to see if you get a difference in a actual watch, and then we'll try zapping it. So let's see what we get on the meter. Okay, so that one was like 39 and it was going to 40 and a little bit above, and then I zapped it and you saw I got it down to like 3 or 4. So I guess it's working better on a wristwatch than a pocket watch. Let me try another pocket watch, just a different one, and see if I can get a similar thing where I can get it down below 10 on this, whatever scale this is. Okay, so the highest I can get that to read is 280, whatever it was, if I move it around on the phone till it's on the sensor. So we'll try zapping this sucker. This is an old West Clocks. And keep in mind, too, it's in a metal case, and it's just cheap metal. That one actually moved a little bit. All right, so let's see if we're any better than what our reading was. Well, you saw what I saw. If I moved it around, I could get it to go up as high as like 600. So I have no faith in this app. So I'm going to try downloading another app and see if we get, good old technology to work. And it could be that app's fine, but not on my phone. Maybe it needs a special type or something. So let me see if I can find something else to do it with. All right, so I Googled it. There used to be an app called Lepsy that was kind of like the go-to standard that everybody liked, but they discontinued that. And so now this one that we're using, people swear by. But the problem is I was putting the watch too close to it. So and it says in the directions, keep it about half an inch away from it. So I was setting it on the phone, and that just makes it go haywire. So if you hold it about half an inch above the phone, and for all you millimeter people, I don't know what to tell you. I guess you can't use this app. But for us Americans, if you hold it half an inch away from the phone, from the sensor, you have to find the sensor on your phone. If you hold it half an inch away, it severely lowers all of the numbers. So, like if I check the screwdriver, it's down at like 6. And so it's giving me much better. So with that in mind, one more time, I'm going to try this one more time. But here we go. Okay, so it was at 100. I move it around. That was the highest I could get. It was 100 if I'm keeping it about half an inch above the sensor. And then I zapped it one more time, and then the highest I could get it was about 10. So I think it is actually working. So that's all I got for that. So if anybody out there can tell why my light isn't lighting up, or what the light is supposed to even do, I wonder if it's like dimly lit up and we just can't see it. No, it's not doing anything. So if anybody knows how that's supposed to work, maybe you can analyze the circuit that we took apart there. Let me know. I'd love to have that part working however it's supposed to. But if not, we'll just leave it how it is. So there you go, folks. I hope you enjoyed it. This is a Magnaflux instantaneous demagnetizer. It's amateur repair time. We really didn't repair anything. I don't think anything got fixed. This might have got fixed a little better. So leave your comments below. Let us know what you think, and I will see you on the next video. And by the way, if you like any of this watch stuff, check out this video. See you on the next one.